Autumn 2017. The world of astronomy was buzzing. Telescopes in Hawaii picked up an object, an odd one, too fast. Flying through our solar system, not in it, coming from interstellar space, for the very first time. They named it Oumuamua. In Hawaiian, it means scout, or first distant messenger. And that name, well, it turned out to be quite fitting. At first they thought it was a comet, gave it a classification. But no fuzzy bit, no tail of gas and dust. So they reclassified it as a space rock, an asteroid. Still didn't quite fit. They actually had to invent a whole new category, I for interstellar, 1I/2017 U1. The first thing of its kind we'd ever officially seen. It shot past the sun at an absolutely incredible speed, 87 kilometers a second. Physics said it should just keep going, bending its path a bit because of the sun's pull, and disappear back into the vastness between stars. But then, Oumuamua did something that completely puzzled every physicist around. It sped up, with no obvious reason. It went off the path they expected, as if something gave it a little push. A tiny, unexplained kick in the empty void of space. And that wasn't the only strange thing. Its shape. It seemed long and thin like a cigar, or maybe flat, like a disc. Its brightness flickered, as if it was tumbling head over heels, not just spinning neatly like a normal asteroid. An object from another star, not like anything we have here, performs an unexplained move, and then disappears from our telescope's view after just a couple of months. Official science says it left, gone forever. But what if that's not the whole story? What if the first distant messenger didn't fly away? What if it hid? Let's look closer at Oumuamua's biggest puzzle, that strange acceleration. Think about it. It went past the sun, and gravity should have just changed its direction. But it sped up, only slightly, just 17 millimeters per second squared at its closest point to the sun. But for something moving in the vacuum of space, that's a massive oddity. Simple physics says you need a force to speed something up. What could that force be? The first idea was the solar wind. That's the stream of particles coming off the sun. It does push things in space. But calculations showed the solar wind couldn't have given Oumuamua that much of a push, not if it was just a normal space rock. Not enough force. The second idea they tried was the comet effect. When comets get near the sun, their ice heats up and turns straight into gas, puffing off the surface. That gas stream makes the comet's tail. It also gives the comet a little kick, like a tiny rocket. We know this happens. But Oumuamua didn't have a tail. Telescopes, even the powerful Spitzer space telescope looking for heat signals, specifically searched for signs of gas and dust, the stuff that makes a tail. They found nothing. Spitzer spent 30 hours trying to get a reading, but got absolutely zero. This meant either no gas was coming off, or it was made of something completely unusual that we couldn't see. And to make things even more puzzling, the Spitzer data suggested something else. Oumuamua was at least 10 times brighter than a normal comet. It reflected a lot of light, which would make sense if it was shiny, maybe even made of metal. An object from another star, speeding up for no reason, no tail, bright, and a strange shape. It's no wonder some scientists started asking the most daring questions. Harvard professor Avi Loeb, a rather well-known and sometimes controversial figure, wasn't afraid of the radical explanations. He argued that if the solar wind couldn't push Oumuamua like a normal object, maybe it could if Oumuamua was extremely, extremely thin, thinner than a millimeter. An object hundreds of meters long, but less than a millimeter thick. That's not something you'd find naturally, Loeb said. So, it must be artificial. a light sail built by an intelligent civilization to travel between stars using the pressure of starlight. This idea got a lot of pushback from other scientists. Most prefer natural explanations first. Counter-arguments appeared. Darrell Seligman, a researcher at Cornell University, suggested, what if the gas was invisible, like hydrogen? He proposed Oumuamua could have been a hydrogen iceberg, made mostly or entirely of frozen hydrogen. As it got near the sun, the hydrogen would turn to gas, creating the push. Invisible gas, no tail, not picked up by Spitzer. But Loeb showed mathematically that hydrogen icebergs just wouldn't last the journey between stars. Even the faint light in space would slowly melt them away over millions of years. The theory didn't hold up. Seligman didn't give up. With Jennifer Berkner, they developed the idea further. What if it wasn't a pure hydrogen iceberg, but a dirty comet? A comet of water ice that, after being zapped by radiation in space for ages, could trap hydrogen atoms inside its structure. When the ice warmed up near the sun, it could rearrange and let this trapped hydrogen out. Not a sudden blast, but a slow, almost invisible release. This could explain the lack of dust, no big blast, the invisible gas, and maybe even the strange tumbling motion. Gas coming out unevenly. They called this the dark comet theory. Loeb wasn't convinced. He kept pushing his alien spaceship model. The debate is still ongoing, but what's key for our story is this. Both natural theories are trying to explain the unexplained acceleration and the missing tail. Those are the two things that make Oumuamua truly unique. So as we heard, Oumuamua was spotted already on its way out of our solar system. We only watched it properly for a couple of months before it got too dim and too fast for most telescopes. The official story is simple. It left, flew back into interstellar space on that path, given an extra kick by its mysterious acceleration. But here's where things get really interesting. There are no confirmed images or radar data of it actually leaving the solar system. The last solid tracking points were inside Neptune's orbit. Why? Because it got further away, dimmer, and its path, already messed up by the strange acceleration, became less predictable. The calculations saying it left were based on a short period of data and the assumption that the weird acceleration carried on predictably. But what if that acceleration was only for a short time? What if it wasn't a constant puff of gas or a steady solar sail push, but a maneuver, a deliberate one? Imagine this. An object arrives at high speed. It gets spotted. They start tracking it. It performs a short burst of acceleration, perhaps to slow down relative to the solar system, or change direction just enough to get off the predicted escape path. Then, it just stops moving in that strange way. It gets dimmer, they lose sight of it, and instead of zooming off into the endless distance, it stays, hiding in the huge, mostly unexplored areas of our own solar system. Think about it. The solar system isn't just the sun and 8 planets. It's massive. Beyond Neptune is the Kuiper Belt, billions of icy bodies. Further out is the Oort cloud, trillions of comets right on the edge. And in between the giant planets, Jupiter, Saturn, are huge areas, gravitational pockets, and special points where objects can stay relatively stable for centuries without attracting much attention. If Oumuamua isn't just a rock or a comet, but something controlled, where would it go to hide and carry on its mission? Somewhere difficult to spot, deep in the outer solar system. And this is where we get into the most speculative, but also most intriguing ideas. What if, after 2017, when Oumuamua officially left, we started seeing unexplained oddities happening in those distant regions, like faint, unusual radio signals that nobody can quite figure out, brief flashes or reflections in the infrared that don't match known objects, or even, for just a moment, a tiny, barely noticeable dimming of a distant star, as if something small, dark but solid moved in front of it on an unusual path. These events, if they happen, are often put down to glitches, bad data, or just left as unexplained. But what if you gather them all up? What if they are traces? Traces of something that didn't leave, but just went into hiding, scanning, collecting data, waiting for something. Picture this. A probe arrives in a new system. It gets noticed. To avoid being fully revealed, it makes a move that looks like it's leaving, disappears from view, and then takes up a position in a blind spot for our telescopes, somewhere in the Kuiper Belt or in a far orbit around Saturn, using the gas giant as a shield against detection. Does that sound like science fiction? Maybe, but no more sci-fi than a space rock accelerating without a tail. No weirder than its shape. Scientists are already talking about dark comets, objects that don't behave as we expect. And what if some of these unexplained events aren't natural dark comets, but active camouflage? And this brings us to the most unsettling part of this idea. What if someone already figured out that Oumuamua didn't leave? What if the most powerful telescopes, the most secret radar systems, or something else entirely that we don't know about, did actually spot it again? Why, after the first few months of excitement, did Oumuamua practically disappear from official reports and the news? Why was it so quickly filed away as gone? Remember the mention in the transcript about other objects with strange acceleration right here in our own solar system. 6 of them. 1, 1998 KY-26, which Japan's Hayabusa 2 probe is actually flying to, is also small, spinning fast, and speeding up for no clear reason. Scientists hope Hayabusa 2 will explain it, but what if its acceleration isn't natural either? What if these objects aren't dark comets, but wish descendants or companions to Oumuamua, smaller probes left behind? And what if the information that Oumuamua stayed was gathered and classified? Too frightening, too paradigm-shifting? Not for the public. There have been rumors, whispers of unusual discussions inside space agencies, of reports marked inertial body of unknown nature. Is it true or just chatter? Hard to say, but the idea itself, it sends a shiver down your spine. What if the scout arrived, did a quick scan, faked its departure, and then took up a position for long-term surveillance? What if it's still here, listening, watching, analyzing our solar system and us? We look up at the sky, build incredible telescopes, send probes to distant planets, searching for answers about our place in the universe. We're looking for life, looking for other civilizations. And perhaps the first contact already happened. Not in the way we imagined, not with a big signal, not with a grand ship, but with a quiet, fast visitor that came, showed itself for a moment, and went into hiding. Oumuamua, the first interstellar object we saw. An object whose behavior defied our physics. An object whose disappearance from view was too quick to be absolutely certain it left. Official science will stick to natural explanations, even strange ones like dark comets. That's right, that's how science works. But as long as those explanations aren't fully proven, as long as there are anomalies, as long as there's unexplained acceleration and that mysterious disappearance, there's room for questions, for doubt, and for the most unsettling thought of all, Oumuamua didn't leave, it just hid. And perhaps it's still out there, somewhere in the shadows of the outer solar system, watching, waiting. So, what do you think? Was Oumuamua just a very strange comet? Or was it the first real interstellar scout? And if so, did it stay here? Did it hide? Let us know your thoughts and theories in the comments below. Where do you think Oumuamua is now? We might discuss the most interesting ideas in future videos. Thanks for watching. If you enjoy exploring the most mysterious corners of space with us, please do subscribe and give this video a like. Your support really helps us make videos like this. See you next time, out in the endless.